So what happened in the last lesson? We have a couple of new students today, and I wouldn't mind some bit of revision. What can we remember that we learned about in the last lesson? Who would like to throw out a few facts or a few ideas? I know we learned about trig graphs. So the basic trig graphs look like this, but we learned a bit more than that. I'm curious to know what you remember. So pop your hand up if you remember anything, or put it in the chat, and I will put it down there. Vertical shift, yes, Clemendo. So a vertical shift, if we close this one off, it's like a plus Q on the end. So we learned about we can shift a trig graph up or down using a vertical shift. We also learned about something else. The stretch, yes, the vertical stretch, what we call the amplitude change. And so we learned in the last lesson about how we can change the amplitude of a trig graph by putting a different number in front of it. And then we also learned about this plus Q, which is a vertical shift. And before I get going with some new stuff today, I actually just want to take a chance to revise an example from this thing that we did in the last lesson. There was something else that helped us do this. There was like a secret weapon. What did we use to help us draw these graphs? Our friend, the calculator. So exactly. So let's bring that calculator back on screen. Let's do that. And then let me, oh, where did you go? Okay. So we have our calculator back on screen. So what I want to start with, and maybe someone can even help talk me through this, but I want to draw the graph of y equals 2 cos x minus 1. And I want to do that on the domain 0 to 360. And I want someone in the class to tell me, what should my first step be if I want to draw this graph? It's had both its amplitude changed, and it's also had a vertical shift. And I want to know, what should my first step be, given that I've got this calculator over here that can help me? What's my first step going to be? You can pop your hand up and tell me, or you can. And for those who are new, you're exempt, because there's some important things that if we want to draw a trig graph, we need to know. How do we get the f of x on the calculator? That's a fantastic question. So let's turn this on. And if I go, normally your calculator starts like this. If you click on mode, and then you click on 3 for table. In the sharp calculators, it's very similar as well, where you just go mode and then you go table. And so what I want to do first is I want to put the formula for the trig graph that I've just given you in here. So you go 2 cos, then I go alpha, because the alpha gets me the red stuff, and then I get type x, and then I close the bracket. And there's still one more thing I need to do. I go minus 1. And that tells the calculator the function I want to draw. The next thing I do is I go equals. And because I'm not drawing a second graph here, I'm just going to go equals. And now the start. Tell me, where do I start if I want to draw this graph? What's the number I'm going to do on my calculator? Yeah, you start at 0 because the question said 0. Here, it starts at 0. Yeah. Okay, now I go equals. Now, where is it going to end? Okay, that's easy enough. It's in the question. So 360, yep. Now we get to this thing called the step size. Now, how are we going to do that? So the step size is related to the period of the graph. So the period of this graph is 360, but that's not going to be the step size. The step size is generally going to be, for the cos and sine graph, the period divided by 4, which gives you 90. Yeah. And the reason it's like that is when we draw the sine and cos graph, we definitely draw them kind of in 4 movements. It's kind of how we draw them. So let's put 90. And then we're going to go equals, and we get this table. Now, what is this table actually telling me? You can raise your hand. Who can give me an interpretation of what this table is telling me on my calculator? Who can explain what the table is telling me? The coordinates. Yes, the coordinates. Perfect. I couldn't have said it better myself. So the very first coordinate is 0, 1. So I go to 0 on the x-axis, and I haven't labeled this, but this is 1, 2, 3, 4. So I'm just going to make a dot from 0, 1. And then my next dot is going to be at 90 minus 1. So maybe I could go here. Yeah, that seems okay. Then 180 minus 3. So 180 minus 3 could be down here. So why did you divide 360 over 9? I didn't divide it by 9. I divided it by 4 to get 90. And I divided by 4 because when I draw the graph, I kind of draw it in 4 movements. That's the honest answer. So let's try 270 minus 1. Let's just make sure I get that right. 270 minus 1. And then 361, which would be up here. So now we have the question of, we have these dots. Now, what are these dots actually drawing? So the dots are drawing the cos graph, but the cos graph has been stretched up and down by 2 and then shifted down by 1. But the good news is we basically play join the dots now, right? Because you know the cos graph moves like this. So, let me try again. I take this dot and the cos graph goes down to start, and then it goes like that, and then like that. And normally we have to label the turning point, which in this case would be 180 minus 3. Let me put these numbers in just so you can see them. And we often label the end point as well, so 361. And what you notice is that if you look at this cos graph, okay, the cos graphs, it's always halfway line is kind of like through here now. You can see because it's been shifted down by 1. The whole graph has been shifted down by 1. And then it's also been stretched. So that's why each of these things goes up or down by 2 units because of this thing in front here. But in reality, you don't need to worry about this blue line too much. You just need to be able to draw the graph. And it feels to me like we would benefit from doing another one of these just to make sure we've really landed this before I move on. So let's draw a graph of a tan graph, and let's make the tan graph y equals 2 tan. So 2 tan x. And so that will change the stretch, but then let's also make it a minus 1. And let's do that on the domain 0 to 360. Now, remember, the step size can actually be quite a few different sizes. And we often use the step size just to help us to know how many points we plot. And too many points would take all day, too little and we don't know where to draw. So try and choose your step size in a way that helps you draw the graph. I'll give you some time to do this by yourself first before I Important you close the bracket. And the start and end are easy because it's 0 and 360. Now here's the step size problem. How big do we make the step size? If we make it too big or too small, it wastes time. So I know that the period of the tan graph is 180. That's the normal period. And I think some people will divide it by 2, but I think dividing it by 4 to get a step size of 45 is the right balance. So I would probably just divide it by 4. Sometimes you'll see people say just to get the step size with tan, divide by 2, but then it's like, if you forget the shape of the tan graph, you don't have enough points. Kimani, I can do it again, no problem. So let me go back to mode, table, and I type 2, then I type tan, then I type alpha, and then I put the X here. I hit that button here, close the bracket, minus 1. So now it's the same graph I've got, and then I hit equals. Then I go equals again because the g of x doesn't do anything. I go 0 equals 360 equals, and then the step size is going to be 45 in this case. Now, there's some errors going on. Can someone tell me what those errors are? Who can tell me what those errors are? Have I made an error, or is that a good error? Yes, Michaela, Echomelo, Andile, these are asymptotes. And because we know there's an asymptote at 90, I'm going to put a dotted line. And what's more, because I know the period of the tan graph is 180, there has to be another asymptote at 270. I'm predicting that, even though I haven't seen the error, but I'll show you it's here. There we go. There's the error there. Okay, so now I need to put my coordinates in. So let's do that. So 0 minus 1. So that would be 0 minus 1 there. 45, 1 would be, okay, maybe I've chosen the wrong. Okay, so this is going to be a little bit sticky because this is going up in 30, 60, 90. So 45 will be halfway between that. So that's 45, and that's going to be 1 over there. Okay, and then what's going on the other side? Let's have a look. 135, which would be here, and that's going to be, let's actually put these numbers in. So that's minus 1, 1, 3. So having the numbers there makes it easier to plot the points. And let me make the color different so that we can notice what things we're going in. So 135 would be here, and it would be in minus 3. So it's going to be down here. And then 180 is going to be at minus 1, which is here. 225 is going to be, so that's 225 is going to be here, and that's going to be at 1. This is actually quite a sneaky one, but that's fine. You can kind of see what's going to happen here. And then 315 is going to be at minus 3, which is down here. And then 360 is going to be at minus 1, which is here. Okay, so now we have to think about the shape of the tan graph. And the thing is, if you know the shape of the tan graph, you know what's going to happen here, right? This is just going to be here, and over here, what's going to happen? This would actually be going further down. Let me do this again. Because I know it has to get close to these asymptotes, right? So, and that's going to get, so it has to get closer to there. And over here, and then I'll stop here. Now, I haven't drawn that perfectly, but you get the basic idea how you join the dots. This should be more curvy. So I'll give that one more go because I think basically it should be going like that. Okay. A little bit tricky, that one, but I think well worth a go. And you notice that the points are here, 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 here. Okay. Thumbs up if you're following what I'm doing. Thumbs down if you're feeling a bit confused. Let's have some feedback from the people of the land. Okay. Now, if you're feeling unsure, don't worry. If we were to bring our calculators back to normal, how would we do that? Good question. We click mode and you click 1 for computation. So that's that. And then mode and then 3 for table to get back to this. Now, if you're unsure, don't worry. We're going to practice many of these, but what I want to do now is I want to move on to the main focus of today's lesson, which is a different type of change. But the method we use is very similar. So you'll see as we go. If I say to you, sketch the graph, but now there's a 3 in front of the x, who would like to tell me what they think that 3 is doing in front of the x? What type of change is that? So it's not a change, it's not an amplitude, it's not a vertical shift. This seems to be a number in front of the variable. Okay, it doesn't shift the graph horizontally, no, but you're getting warmer. This is what's called a period change for the graph. So it changes how quickly you get through a period for the tan graph. I mean, not the tan graph, the sine graph. Normally, the period of the sine graph is 360. But because of that 3 in front, the new period of this graph, okay, so the period of f is going to be 360 divided by 3, which is 120. So this now, if the period of the graph is now 120, I want to ask you, what is the step size going to be? What do you think the step size is going to be of this graph? Pop it in the chat or pop it in. I want everyone to have a go at this. Okay, so what does it change? Okay, it changes the period of the graph, and the new period of the sine graph, when there's a 3 in front, is just the old period divided by whatever the number is in front of x. So the new period is 120. To get my step size, I'm going to take the new period and divide it by 4, and I get 30. Okay, now, I want you to use the same method we were using now, but I want you to try and draw this graph on the domain 0 to 360. So I'm handing this over to you. It is a different type of change, but I think using your calculator, you can type this in and figure out what it looks like. So I'm going to give you 2 minutes to do that, and then I'll do it on the calculator and give you feedback. Over to you guys.
Have a go at it, guys.
Hey, what are we doing? So if you should be able to type sine 3x in your calculator. So Gepotso, the step size wouldn't be 90 in this case because the period has changed to 120. The step size also has to change, and it changes to 30 now. So you take the new period and divide it by 4. And so, oh, I went too far. Let's try that again. So equals. So I start at 0. I go to 360. And my step size is going to be 30. Okay, and now we have these coordinates that we want to put and see if we can get a graph from them. I'll just draw these in so that you can see what they are. Then what's this? This is 1, and that's -1. I'm sensing a bit of a pattern here. I don't know if you see it as well, but it feels like I'm just going down and up in these jumps of like, there's one step. Let me try again. So the one step goes to there, then another step, then another step, then another step, and that's one full period of the sine graph. Now I go again. And this is why we call the sine or the trig functions periodic, because they repeat themselves like waves. You can see it's just going. And this would be one full period of this graph. And you can see another full period over there. And you can see another full period over there. So you get 3 full periods in 360 degrees because this new 3 has changed everything. Now, sometimes in exam questions, they say label the turning points, which would be these points, or label the endpoints, but that's all you need to do. So Mwenje, I will repeat the steps on the calculator for you, no problem. So let's go to mode. So table, and you type sine 3 alpha x close. Okay, now you go equals. Now, some of you will have this g of x, some of you won't. Doesn't matter. You go equals. Start with 0. Then we'll go equals, end with 360. And that's because of this 0 to 360 here. And then the step size was 30. Okay, now I'm going to give you another question, and then we'll take a break. I want to draw the g of x, which is going to be the sine of 3x minus 1. And you're also going to draw this graph for me on the domain 0 to 360. So you are going to draw it on the same Cartesian plane, and I want you to draw this graph. We can draw it in red to make it contrast, and I want you to draw it and see how it compares to the graph F. Over to you guys. Maybe tell me in the chat, for those who've got a bit of spare time, what do you think is happening here? What do you think the -1 is doing to this graph? I'm curious to know if you can predict what it's saying. Or what it's doing, rather. Yes, Lumelo. It's just moving the graph down by 1 unit. So I would expect, if things go well, that this graph should reappear, just everything move down by 1 unit. Katlego, I agree. Michaela, same thing. You are on the money. Now, what about the step size? Now, because the period of the graph is affected by this 3, it's going to have the same effect that it had before. The step size is still going to be 30 for this one. So we'll make it 30. And there's my table. So let's see what points I get. I get 0, -1. I get 30, 0. I get 60 -1. I get 90 -2. I get 120 -1. 150, 0. 180 -1. Let's have a quick look. It does appear that the prediction of it just moving down by 1 is exactly what seems to be happening. So 210 -2, 240 -1, 270, 0. You can kind of see the pattern is still continuing. 300 -1, so that would be down here. 330 -2, 360 -1. Yeah, and so this would be the graph of G, and this was the graph of F. Okay, so once you know how to use your calculator, even if we make it a period change, as long as you know what this number is doing and you can do the bits of working out, the drawing is like join the dots. So give me a thumbs up if you're following along. Give me a thumbs down if you're feeling a bit lost. I just want to get a quick group feel for how the people of the land are feeling here. Okay, fantastic. Now, we have worked hard now for a solid half an hour. So we are human beings. Our bodies need to move. And so let us stand up and take a moment for ourselves to just unwind. And what I want you to do is I want you to stand on your tippy toes and see if you can touch the sky. Woo. Okay, wait.
Please turn on your cameras, guys. Let's see your lovely faces.
My stomach muscles are like feeling this. So see if you can stand on your toes and see if you can point towards the sky. Your calf muscles should also feel that. Oh, definitely. And then let us do a little tricep stretch. So we'll do that. Let's switch over. And then do a little front arm stretch like this, where you stretch across, you look up in front. Like this. Okay, and now I want you to shake out your arms, get nice and loose like your rubber bands. So just do this. Shake out this arm. Get nice and loose. Maybe you can do the wavy thing. And then you can shake out your legs. Just get nice and loose. Just shake everything. And then let's bend to the side like we're a windmill. I don't know why I'm doing this, but it is good. Bend to the side like this. Oh, there we go. Hearing good clicks. And then let's do some heart rate inducing stuff. So let's do some jumping jacks. Let's just do 15 today. Jumping jacks just like this. So we'll do 15 and we'll start in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And shake out your arms one more time and just feel nice and loose.
Awesome, guys. Hopefully you're feeling refreshed after that.
Yes. And let's just have a quick brain break. So here are your Maths 24 cards for the day. To the winners go the glory. See if you can figure out any one of those cards. You have to be able to make 24 using all 4 numbers. You can only use each one once, and you only have the normal operations. So over to you guys. Who feels like they have Maths 24 under control? You can go for a red, you can go for a blue, you can go for a yellow. Lelo, what have you done? You've got 8 times 8, which is 64, divided by 64 divided by 2 is 32. And then times 1, no, so we don't get 24, but it's a good effort, but no 24 for that. Then, and to cause, or I wish I could say you're right, but that's a 6, not a 9. So this is a 6 because the bar is at the bottom. Yeah. So normally we try and make the factors of 24, right? So like 6 and 4, 8 and 3, that type of thing. So Kitzel has said 8 minus 7, which is 1, plus 2, which would give you 3, times, oh wait, no. Oh, that could work, times 8. So 8 minus 7 is 1, plus 2 times 8. Let's check, so 7, 8, 8, 2. And then that gives you 3 times 8, which is 24. Yes, Kitzel, the blue one is yours.
Well done, Kitzel.
There we go. Anybody want to have a crack at the red one? Or the yellow one? Those are still available for doing tonight. So Paul has said for the red one, and 8 minus 6 plus 1, which is 8, 6, 1, and that gives you 3, and then times by 8, which gives you 24. Yep, that is
nicely done, Paul.
And then Nkazimodo has said 8 minus 4, but I don't see a 4 unless I'm 9 and 2 I see. So there's a 9 and a 2, but then you've only got an 8 and a 7. So yeah. So you're close, but not quite. All right, then I'm going to leave the yellow thing for now, unless someone gets in at the last second. Let's go back to the lesson. And let's go on to drawing this graph. So I want you to draw, in fact, let's do these 2. So here are the 2 graphs that I want you to draw. I want you to draw the graph of y equals sine 2x, and I want you to draw it on the domain from minus 90 to 180. And then after you've done that, I want you to draw the graph of y equals cos 3x, and I want you to draw it on the domain 0 to 360. Okay, over to you. I will bring the calculator back in a moment, but I want to see if you can fly solo for this one. and think about how does the period of the normal sine graph change, and then how is the step size, and then think about that for this one here too. Okay. Let me just bring the calculator back. There we go. So we have, I suppose we need to think about the period of the graph. So the period of this graph is actually going to be 180. And then the step size is going to be 180 divided by 4, which is 45 degrees. So I'm putting in these different domains that they asked, and the step size was 45. So my table looks like this. Yeah, I'm not going to label it. It's getting a bit too cluttered if I try and label it, but sometimes you have to label the points. But okay, so that was the first one, sine 2x. And what we notice is that it's just going up by 1 and down by 1 every 45 degrees, which is the step size over here. Okay, what about the second one, cos 3x? How would that be different? So So 0, 1, 13, 0. And what I'm starting to notice is there's definitely a pattern, right? You can see this is the cos graph, and you can see it goes down, down, up, up. And then it just seems to start again. And this is what the points will tell you. And you get how many? You get 3 full periods. Like you get a period from here to here. Then there's another period that goes from here to here. And within 360, there's 3 full rotations like that. So I wanted, are there any questions about these two where I lost students? It's hard for me to tell what the appropriate speed is. Are there questions about using the calculator? Are there questions about the way I'm drawing it? Are there questions about my working out? Otherwise, if you're feeling good, give me a thumbs up in the chat, just so I know about your general feeling about the question. Otherwise, I'll wait for questions for a little bit. So I encourage you to ask a question if you are feeling unsure at this stage. Okay. Not quite there yet, but we're getting there. We're getting there. So let's do another one. Let's do one involving tan, because I feel like we've neglected tan a little bit. So let's do this together first. I want to ask you, there's a half in front here of the tan, and this half is going to change the period of the tan graph. What is the period of this tan graph? And I want you to put, so I'm going to talk about the steps now in a moment. Yeah. So what do we think the period of this tan graph will be? The normal period is 180, but I think the half is going to change it. So what I need to do is I always take the old period and I divide by the number in front of the x. So tell me what that is. What's 180 divided by a half? It's going to be 360. Exactly. Now with the step size, even though we draw the tan graph by drawing it in 2 halves, I do think it makes sense to still keep your step size by dividing the period by 4, because it gives you enough points that you can see the shape. And so what I'm going to say is the step size is going to be the period of this graph divided by 4, and so the step size is 90. Okay, now you have the period of this graph, you have the step size. I want you to try and draw for me the graph of tan a half x over the domain minus 360 to 360. And I want to give you 2 minutes by yourself before I start plugging things in on the calculator. Give it a go. Hang in there, yeah, hang in there. I know it's tough. It's a dark and stormy night, but we are mastering our calculators. And what this is going to mean in matric is that you guys are going to be like, trig graphs, get your calculator, boom, full marks in the bag, moving on. So that's why we put in the hard work now. So what am I going to put here? I'm going to put 10.5 or half alpha x close brackets, and then equals, start at minus 360, end at 360, step size is going to be 90. And we have errors, goodness gracious, but we actually know with the tan graph, we expect there to be asymptotes somewhere, and the errors just tell us where the asymptotes are. So there's an error there, and there's an error at plus 180, which makes sense because the period of this graph is 360. But now we need to plot these points so that they make sense. So minus, let's put some numbers in here too. Like if this is a 1, 2, 3, 4. These blue dots. So minus 360, 0, minus 270, 1, minus 180 error, minus 90, minus 1. Then it's 0, 0. And it's 90, 1. Then it's 270 minus 1. And then it's 360, 0. So you've got all these dots. Now you need to think about what is the shape of this graph, but you know it's the tan graph. So you just have to make sure that you get the correct. So there's the one half of it. I just like to draw it in half. So that's the first half. And then here is the second half. And you know that it gets closer to the asymptote, but never gets there. And then on this side, it's going to look like that. And then on this side, it's going to look like that. And then you would label the graph. And also on the tan graph, what they quite like you to do is they like you to often to give the value kind of where it's at 1. So basically like to show that at 90, this is equal to 1. Now that was a bit trickier because it was the tan graph, but the process we seem to be following with our calculator seems to help us every time. So I just want to pause for a second and ask for questions. Are there areas you would like me to clarify or go over? Otherwise, maybe we can squeeze in one more for tonight. But I just want to pause for a second to ask for any questions. Any questions or comments? Would you like one more for the road? Oh, why is the period of the tan graph 180? So Melo, it's got to do with the fact that the tan graph is actually made up of the sine graph and the cos graph. And so it's actually not like an original, it's kind of related to it in that degree. So that's sort of, it's a bit different to the sine and cos. So that is the one way that I'll leave it for now. There is other ways of explaining that, but I'm going to just say that it's a bit different to sine and cos because it's made up of sine and cos. On to a question that has no number after tan, sine, cos. Okay, well, I was thinking, why don't we do one which has, let's do the graph of y equals 2 sine 2x. And I want you to draw that for me on the domain minus 360 to plus 360. In the next lesson, we can make up whichever ones we like, but this is, now I've changed, now I've changed the number in front of the sine, which is an amplitude change, but I've also changed the period of the graph. Can you draw that trig graph for me? On Tukoza, what do you mean by, is it possible no number after the tan, sine? You have to have something sine and then a number, or sine and then a variable. Yeah. Let's finish with this one for today. Let's see if we can draw this one. So 2 sine. Wait. 2 sine 2 x. Now, what is the period of this graph going to be? Well, the number in front, the yellow, doesn't affect the period. It's just the green one. So the period of this graph is 180, and the step size is just going to be 180 divided by 4, which is 45. And the reason I'm choosing divide by 4, because that gives us enough information that we can see how it's being drawn. Let's see, start minus 360, end 360, step 45. Then we're going to get minus 360, 0, minus 315, 2. It feels like there's a bit of a pattern going on here. That's 1. That's 2. Okay, so I see we're running out of time for tonight, but what I've done is I haven't actually used all the points on the calculator. I just looked at the pattern. I went, every 45 degrees, I got up by 2, down by 2, down by 2, up by 2. And that gives me the pattern that it's been stretched vertically and it's also been compressed horizontally. I wonder is also the 2 in front of f of x is 2 sine 2x. The 2 in front stretches the graph to go between 2 and minus 2, when it used to only go between 1 and minus 1. And then the 2 in front of the x forces the graph, instead of fitting a whole cycle into 360, you can now fit 2 whole cycles within 360 because the period has been changed to 180.